Questions and solutions. Given the integration of f of t dt between 1 and 2 equal to 5. Find the integration between 2 and 1 of the function open parenthesis f of t plus 2 close parenthesis dt. The way to handle this one is to break it into two functions, and here are the two functions. Integration between 2 and 1 of f of t plus 2 dt equal to integration between 2 and 1 f of t dt plus integration of the number 2 between 2 and 1 dt. And this is equals to, because we're going to change the limits, this is equal to negative of integration between 1 and 2 of f of t dt, which is equal to 5, as we see over here, minus integration between 1 and 2 of the number 2. We can proceed with them as follows. This we already know that without the negative 1 multiplied, this will give us 5 based on this equation. So negative 5. And this we have to integrate 2 dt, that will give us 2t, and we have to evaluate the 2t between 1 and 2, where 1 is lower and 2 is higher. If we do the math, we're just going to have and plug in 2 instead of t, and then minus plugging 1. That will give us 4 minus 2, and the ultimate answer will be negative 5 minus 2, and that will give us negative of 5 plus 2, which is equal to negative 7 divided by x ln x. So we want integration of the function 3 divided by x ln x dx. Let u equal to ln of x. This implies du, which is derivative of the left, equal to 1 over x dx, which is derivative of the right. If we multiply both sides by x, we get dx equal to x times du. Now we just plug in, instead of ln x u, instead of dx, we will put x du. That's going to be something like this: integration of 3 divided by x, and this is u, which represents ln x, and this is x du, which represents dx. Now we can see that the x cancels with the x, and we have just integration of 3 divided by u du. So we take the 3 out, we'll have 1 divided by u du. Since the derivative of u is equal to 1, because we're integrating with respect to du, then this will yield 3 ln of the absolute value of u plus a constant, because we don't have like integration from lower limit and upper limit, and that's why we have to put the constant of integration. That's going to be equal to plus c. So our final answer will be 3 ln of the absolute value of ln x plus c. That is the answer for this problem. Find the integral of 3 e to the power 2x cosine of e to the power 2x dx. We will also use integration by substitution. So let u be equal to e to the 2x. Then du is equal to 2 e to the 2x dx. This implies dx equal to du divided by 2 times e to the 2x. Now we will just be plugging in values. So integration of 3 e to the 2x cosine of e to the 2x dx is going to be equal to integration. We leave 3 e to the 2x aside. Cosine, instead of e to the 2x, we replace that by u, and then we multiply that by dx. We know that dx is equal to du divided by 2 times e to the 2x. So we replace it here, du divided by e to the 2x. So e to the 2x cancels e to the 2x, and we'll have 3 divided by 2. We'll take it outside of the integration, and that's what we have, 3 over 2, and then integration of cosine u du, neat and clean. So integration of cosine u is going to give us sine u. So that's going to give us sine u plus constant. So 3 divided by 2 sine u plus constant, and that is the answer. So the answer is 3 divided by 2 sine. Instead of u, we replace it by the value of u, which is e to the 2x plus constant, and that ends this problem. Replace the integrand by its equivalent trigonometric value. What we have here are just algebraic expressions in terms of a rational function. We want to replace the integrand, which is this, we want to replace it by trigonometric functions. To do so, we have to think about what value x should have. So let x be equal to 1 over 3 tan theta. If x is equal to 1 over 3 tan theta, let's do the derivative of both sides. So dx will be equal to 1 over 3 sec square theta d theta. This implies the following. Integration of 1 divided by x square, square root of 9x square plus 1 dx equals to integration. We're going to leave x square as it is for now. And then numerator is the same, 1 divided by, in the denominator, instead of x square, we're going to plug in its value. If x is equal to 1 over 3 tan theta, then x square will be 1 over 9 tan square theta, which is right here, 1 over 9 tan square theta. So this x square in black is replaced by 1 over 9 tan square theta in blue. Now we can see the 9 cancels the 9, and we'll be left with tan square theta plus 1. But also dx has this red value, which is 1 over 3 sec square theta d theta. So we replace dx. This dx is replaced by 1 over 3 sec square theta d theta. Now we can do some cleaning. We can see that x9 cancels the 9, so we have tan square theta plus 1 inside. And outside we have 1 over 3. 1 over 3 is coming from dx. So we have 1 over 3 and then 1 divided by x square, square root of tan square of theta plus 1 multiplied by, this is part of the dx equivalent, because the 1 over 3 we move it to the left of the integration. So this is what's remaining in red is from the equivalent of dx. Let's move on to the next step. So we have 1 over 3. Now we're going to have to replace x square by its value. We know that the value of x square is 1 over 9 tan square of theta. So it's right there in blue in the denominator. Instead of x square, we replace it by 1 over 9 tan square of theta. But we know that 1 over 9 takes 9 to the numerator. So the 9 could go up here. That will be 9 over 3. And then we have tan square theta multiplied by sec theta. Where did we get sec theta from? We know that the square root of tan square plus theta is same as the square root of sec square theta. That is tan square theta plus 1 equal to sec square. And since we have the square root of sec square, we're going to get sec theta only. So sec theta is the result of replacing the square root of tan square theta plus 1, because tan square theta plus 1 is equal to sec square theta. So the square root goes and we will have sec of theta. And this is multiplied by the remaining of the dx equivalent, which is sec square theta d theta. Now we can see that we can cancel one of the sec from the numerator. So the denominator will cancel sec of theta. So we will have only just sec theta. You can see we have sec theta here and no sec theta in the denominator, just sec theta in the numerator because this is sec square theta. So we have 9 over 2 integration between 1 divided by tan square of theta multiplied by sec of theta d theta. Let's go ahead and rewrite tan theta. Okay. We could just flip this up. Instead of tan theta, it would be cotan of theta square. Instead of tan theta, 1 over tan theta square, we will put cotan theta square. And that will give us what? Cosine square of theta divided by sine square of theta. And of course, 9 divided by 2 will give us 3. So cosine square theta divided by sine square theta multiplied by sec of theta d theta. We know that sec is the inverse of cosine, so even this sec theta in red is going to take care of one of the 2 multiplied cosine theta. Now, cosine theta multiplied by cosine theta, so we're going to get rid of one cosine theta. We'll be left with cosine theta only, and sec theta will disappear with the other cosine. So we will have just cosine theta divided by sine square of theta d theta. We don't have to carry on the integration. We just want to replace this integration to integration of the integrand, which is trigonometric function. So let's go ahead and look at this. This is equivalent to 3 multiplied by cosine theta divided by sine theta multiplied by 1 over sine theta d theta. So we can rewrite this one as 3 integration of, this is cot theta, so cot theta, and this is cosec theta d theta. And that ends this problem. Now we have to compute the integral of x to the power 5 plus 2 divided by x squared minus 1 dx. And this is a little bit difficult, so we have to do the division. We cannot just factor out the denominator. That would be a long way, and we may not even get even there. So let's just go ahead and do division. We divide the numerator by the denominator. So if we divide x to the power 5 plus 1, x to the power 5 plus 2, if we divide it by x squared minus 1, the result will be as follows. Let's follow it step by step. What we're going to divide is x to the power 5 plus 2. The divisor is x squared minus 1. Since x to the power 5 is greater than in order of x to the power 2, then we can divide this. So x to the power 5 divided by x to the power 2 will give us x to the power 3. Now, since this is x to the power 3, we have to multiply it by the divisor and list it down. So if we multiply by the divisor, x to the power 3 multiplied by x to the power 2 will give us x to the power 5. And then x to the power 3 multiplied by negative 1 will give us minus x cubed. Now we have to subtract this line from the top line. So x to the power 5 will go with x to the power 5. And we have 2. And then we have to subtract from 2 negative x to the power 3. So it will be x to the power 3 plus 2, all positive. Now x to the power 3 is greater in order than x to the power 2. So we can perform division. X to the power 3 divided by x to the power 2 will give us x. So we will put plus x here. Now we have to multiply x by the divisor. So x times x squared will give us x cubed. Then x times negative 1 will give us minus x. Now we have to subtract this line from the line on the top. We can see that x cubed goes with x cubed and we'll be left with 2 minus negative x. So it will be 2 plus x I just put it as x plus 2. Now the division resulted in this, the result, this is the divisor, and this is the remainder. So we can rewrite the function x to the power 5 plus 2 divided by x square minus 1. We can rewrite it as x to the power 3 plus x, which is what? Which is the answer. Okay, so this is the answer. So we put that without involving anything else, and then plus the remainder we have to divide it by the divisor. So the remainder is x plus 2. We have to divide it by the divisor, which is x squared minus 1. So we'll do it in two terms. So we'll say x divided by x squared minus 1 plus 2 divided by x squared minus 1. Now, to do the integration of the left-hand side, we have to perform the integration term by term of the right-hand side. So do the integration of the first term. It will give me x to the power 4 divided by 4. Second term will give me x to the power 2 divided by 2. Third term, we can see that we can use ln. Why? Because the numerator is not really the derivative of the denominator. We have to make a trick, and the trick is we have to make the numerator derivative of the denominator. What's the derivative of the denominator? Is 2x. So we have to multiply 2 on the top, and then we have to divide the result by 2. So dividing by the result by 2 is just writing 1 over 2. And then if we take the integration of 2x divided by x squared minus 1 will give us ln of the absolute value of x squared minus 1. I mean, by now we should be able to understand that the result of integration of this is going to give us half of ln of this. And then from here on, we have to do this one. So this one is 2 divided by x minus 1. So this is the whole integration that's left. All the integrations on the previous ones are done except this. So this one we have to do integration by parts. And 2 divided by x squared minus 1 will be equal to a divided by x minus 1 plus b divided by x plus 1. If you do cross multiplication, you're going to get the left hand side will be the same, right hand side will be ax plus bx minus b. And if we rearrange, we know that we have two coefficients, coefficients of x and coefficients that are coefficients of x to the power 0, or constant terms in other way. So if we look at the constant terms, we have only one constant term, which is 2. That means 2 is going to be equal to the constant term over here, which is a minus b. We have a as a constant term and b as a constant term. So a minus b is equal to 2. And the coefficient of x, of course, we have ax plus bx. So a plus b is a coefficient of x. And coefficient of x here is 0. So a plus b equal to 0. Now if we add these two, it will give us 2a equal to 2. That means a equal to 1. And since a plus b equal to 0, so b must equal to negative 1. And if that is the case, we're just going to go ahead and plug in instead of a 1, plug in instead of b negative 1, and do the integration. And if we do the integration, we're going to get this. The first will give us ln of absolute value of x minus 1 minus the second will give us ln absolute value of x plus 1. Okay, and then we can just group these two in this in green. It will be ln of the absolute value of x minus 1 divided by x plus 1, the absolute value, plus constant, because this is the constant of integration. This is the answer of the integration. This could be rewritten in a different way, but we're going to stop right here, and that ends this problem. Let's go to the next problem. This is the last question, and it's about using the velocity formula. V of t equal to t squared minus 6t plus 8. This is the formula for the velocity of an object moving on a straight line. We want to find the distance traveled between t equal to 0 and t equal to 3. We can do that by just taking the distance. The distance is the integration of the velocity. So integration of the velocity is going to be integration of t squared minus 6t plus 8 dt. And that's equals to, term by term, this will be 1 over 3 t cubed minus, this will be 3t squared plus this will be 8t, and of course we don't want to add a constant because we know that we have the limits of the integration 0 and 3. So we'll just go ahead and do the plugging. So to find d of t between 0 and 3, these are the limits of integration. We evaluate the distance between 0 and 3, but we know that 0 is going to result in 0. So we'll just evaluate the function and replace for every t the value 3, and that will give us the distance. If we do so, 1 over 3 multiplied by 3 to the power 3, that's going to give us 3 to the power 3, it's going to give us 27 divided by 3 will give us 9, and this is 3, negative 3 multiplied by 3 squared. 3 squared is equal to 9. 3 times 3 squared is going to give us 27, so minus 27, and 8 multiplied by 3 will give us 24, and if we do the math we can see that this will result in 6 meters because the unit is meters, so the distance traveled will be 6 meters. And that's the end of this, and that ends the quiz. So good luck and see you for the next quiz.